Okay. Okay. The next part is I will explain another example. Okay. Please refer to this page. This section. Page. I will see you another example here. Let's see. I would like to choose. Okay. This example. I hope you also upload download this graph. Okay, I have this graph for to explain to you how to find the minimum or extreme value or critical value based on this equation. Okay, please. I hope you also have this file. Please download from the UKM folio. Okay, let's say this graph for cubic function, graph for cubic, there is fx equal to x to the power of 3 minus 9, 8x squared plus 24x plus 2. Okay, there is a cubic function. Okay, I also share with you the graph, the graph for this function, and then you can see here this graph has at the first part the graph is increasing. The graph is increasing when we move from left to the right. When x increase at the first part, the value of y is increased, and then after certain point you can see the value of y is decreasing, the value of y decreasing, and then increase again after the certain point, certain value of x. Okay, that show that this graph has the slope of this graph is changed when x move from the when the value of x change when the value of x increase from the negative to the positive. And then I will now we can apply in this now I will show you how to determine how to find the slope of the function uh, and then how to find the critical point in order to determine the area of the where the function is increasing or decreasing. For example, from this graph, we can see here clearly, we can clearly see here that there is one point here, and then we have a second point here. When x equal 2 and when x equal 4. Before 2, the slope of the function is positive. As you can see here, the value of y increased. But between 2 and 4, you can see here the value of y is the value of y decrease, or the slope of the function is negative between 2 and 4. And then after x equals 4, we can see again the value of y increase when x increase, or the slope is positive. But now I will show you how to apply the dy dx in order to determine the critical value and also to find the increasing or decreasing area for this function. Okay, based on this concept, first we need to find the first derivative. Okay, the first step is to find the first derivative, dy dx, f prime x, or dy dx. So this is equal to 3x to the power of 2 minus 18x plus 24, and equal this equation to 0. When we equal the equation to 0, we know that we just want to find whether equal 0, meaning that the slope of the function at that area is equal 0. Okay, that's the example. So you can use your calculator, or you can apply the quadratic method, and then the answer is x equal 4 and 2. If x equal 4 and 2. Sorry, 4 and 2. Okay, what does it mean? Okay, this show that when x equal 4, the slope of the function is 0. The slope of the function is 0 at this point. When x equal 2, at this point, when x, the first derivative when x equal to is 0. Okay, how to write this? Okay, I just want to show you f prime 2 is 0, and then f prime 4 is also 0. To show that there is a two critical point. Is a two critical at this critical point, the slope of the function is equal 0. That's the uh, the critical point, the slope, the first derivative is 0. Okay, now we know that for this function, the critical point, this function has two critical points. The first, there is x equal 2 and x equal 4. At these two critical points, the slope of the function is equal 0. Besides that, we can also draw a horizontal line. We can draw the horizontal line like this to show that the slope of the function at that point equal 0. Now we can after that we can uh, uh, we choose any point that below than 2 in order to determine what for example, let's say I would like to know when x equal 1, for example, x equal 1 at this point, what is the slope? Find the slope of the function when x equal 1. So I just find f prime 1. We just substitute. There is, let's say, for example, there is a 1 to the power of 2 minus 18 times 1 plus 24. Find the answer is 9. The slope of the function is 9. That is positive. At this point, f prime 1 is positive. The slope of the function is positive before x equal to. I just choose what x equal 1. You can choose any number. You will find that the slope is still positive, but the value of the positive might be is different, but the sign is still positive. Now I would like to choose I want to find the slope of the function between after 2 but before 4, between these two critical points. Let's say at point x equal 3, this point. So f prime 3, the slope of the function is equal to 3 to the times 3 to the power of 2 minus 18 times 3 plus 24. So the answer is you can get the answer is -3. That is negative. The slope of the function at this point f prime 3 is negative. It's negative or negative 3 is -3 equal -3. So between these two critical points, the slope of the function is negative. The slope of the function is negative. Okay, that's quite interesting. So we can see the slope of the function change from positive to negative before and after critical point of 2, x equal 2. And then the next one, I would like to choose any value of x but greater than 4. What happened to the slope of the function after the x equal 4? So let's say I choose 7. F, I just choose it randomly, but as long as the value of x is greater than 4, I choose 7. You can see here, 3 times 7 to the power of 2 minus 18 times 7 plus 24 You can see the answer is 45. That is positive. At this, for example, at this point, when x equals 7, for example, the slope of the function at this point is equal 45. That is positive. So you can see here, before x equal 2, so we can conclude here this function has two critical points, x equal 2 and x equal 4. Before x equal 2, the slope is positive. Between 2 and 4, the slope is negative. Between after 4, after x equal if x greater than 4, the slope is again positive. So we can conclude here that the function is increasing. The function is increasing in interval from negative infinity until positive 2 and 4 until positive infinity. The function is increasing, or the function has a positive slope. And then the next one is this function is decreasing. The function is decreasing, menurun, in interval x between x equal to and 4. This is the conclusion about the function, whether the function is increasing and decreasing. We know that for this function, this function can increasing or decreasing subject to the value of x. Before 2, the function is increasing. After between 2 and 4, the function is decreasing. After x equal 4, the function is increasing again. So that's how we can apply the dy dx in order to find to determine whether the function is decreasing or increasing. Okay, this the first scenario. The second scenario is since there are two critical points here. There are two critical points. We would like to know which point is a maximum and minimum relative. So this critical point is also known as a extreme value. So now we need to know the which point is a positive, or which point is a maximum or minimum. First, we just take the second derivative. Okay, the first derivative of the function is this 3x squared minus 18x plus 24. The second derivative, we get 6x minus 18. Okay, now we just substitute x equal to 6 times 2 minus 18. There is we got 12. This is negative 6. This is negative. And then the second, this show that since the second derivative is negative, so we can conclude that the function is concave down. Concave down. So x equal to is a maximum relative. Based on the graph, we can write here that the second derivative is negative. It's that. So the first critical point is a maximum point for the function. So the second critical point, now we move to the second critical point, x equal 4. The 6 times 4 is 24, minus 18 is equal to positive 6. So the second derivative of the function is at x equal 4 is positive. So based on this situation, we can conclude that when x equal 4, the function is concave up. So the critical point is the x equal 4 is a minimum relative point. Minimum relative point. So based on this graph, we can conclude the second derivative at this point is positive. So the function is concave up. So this function has two critical points. There is x equal 2 and x equal 4. At x equal 2, the critical point is the maximum relative point. But when at x equal 4, the critical point is a minimum relative point. So based on this example, we can, based on the example, we can conclude, we can define, we can determine the area where the function is increasing or decreasing. And also we can find the critical point. At the same time, we can also determine whether which critical point is positive and minimum or maximum relative. In order to this is the example how we can apply the first derivative and second derivative in order to identify the extreme relative point for program. Okay, that's about this example. Okay. Okay. So if you refer to my lecture note part C, there is a few example here. I hope you can uh, review the another example. Example for there are a few functions here. I hope you can review, and then I hope that can help you to understand how to find the increasing or decreasing area, how to determine the critical point, and also how to find the maximum or minimum relative. Okay, that's about the application, the concept of first derivative and second derivative. Okay, the last part for today is about the application of maximum and minimum. Okay, please refer to page. Its application is please refer to page 11, 12, and 13. Okay, there is again a few examples. I will focus the last example in order to find the this example is very important because they include the total revenue, total cost, and also the total profit. All right. Okay, please please refer to page 30. I will show you step by step how to answer the question, how to apply the maximum and minimum. Okay. Okay, any questions so far before I continue? Any question?
No.
No, doctor.
Okay, thank you. Okay, the last part for today is about the application of maxima and minima. Okay, for example, please refer for page 30. Let's say given the demand equation or demand function P, we have P, the demand function P equal to 400 minus 2Q, and also given the average cost A, C or C bar equal to 0.2 Q plus 4 plus 400 divided by 400 divided by Q. Okay, that is we have a demand function here. Again, this is a demand function. Demand function. So this is an average cost. Demand function and average cost. Okay, I will explain later what is the average cost. Okay, basically a demand function I have explained before. What is average cost? Average cost is equal to the total cost divided by the quantity. Or TC divided by Q. There is a total cost. Okay, so the first question is, let's say the first question is find. The first question is find quantity that maximize profit. We need to find the quantity that maximize profit. So how to find, how to solve this equation, how to find the quantity, the Q that maximize maximize profit. Okay. So the tip is, first we need to know the function. This function, as the question asks you, find the quantity that maximize profit. We need to, the answer is Q equal to blah 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 blah. But the first thing we need to know is what is the profit function, because this question asks you to find the quantity that maximize profit. We need to know what is profit. So profit is untuk. What is profit? Profit equal to TR minus TC. Total revenue minus total cost. So the first of all, we need to identify what is TR. Based on topic 1, I think I explained a lot about this TR. TR is P times Q. P is a demand equation. 400 minus 2Q times Q. So the answer is, we know the TR equal to TR equal to TR equal to, for this case, TR equal to 400 Q minus 2Q squared. Okay, I need to screenshot this first. Okay. Okay, now we have this TR. Okay, I just continue to form here. Okay. Okay, so TR equal to 400 minus 2Q. The next part, we need to know what is TC. We need to find the TC. So TC given in the question is AC. We have AC here. Given in the question, we have AC. So the average cost. So in order to find AC, so AC equal to TC equal to AC times Q. So we have AC here. AC is 0.2 Q plus 4Q plus 400 Q. 400 divided by over Q times Q. So TC equal to 0.2 Q squared plus 4Q squared plus 400. This is TC. Okay, first, then we need to identify what is TC. So therefore, pi equal to TR 400 Q minus 2Q squared. This is a pi minus TC. TC is 0.2 Q squared plus 4Q squared. Sorry, for 0.2 Q plus 4. So you plus I think 0.2 plus 4Q. Okay, it's not 4Q squared. This is a 4Q. This 4. This 4. 4Q plus 400. So we get pi equal to negative 2.2Q squared plus 369Q minus 400. This is the pi equation. It's a pi equation. So in order to answer the question, we need to know the profit function first, because the question asks the question is about the quantity that maximize the profit function. So we need to know the quantity the profit function first before we can find the quantity. So in order to find this quantity, in order to find the quantity that maximum profit, we just take the first derivative, dq d pi dq, or pi prime. So this is a negative 4.4q plus 3696 equal 0. Equal 0. So q equal, we just solve the question, q equal 90. Okay, that is the answer. That is the quantity that maximize profit. So the next question, what is the price? The next question. So based on this question, in other words, we need to apply the basic concept of the dy dx, the first derivative, the dy dx, in order to determine the maximize or minimum. In this case, we need to determine the maximize. Okay, so since the answer is q equal 90, okay, first we need to justify whether this q equal 9 is a maximum profit. This is a maximum point. How to find the maximum point? We just take the second derivative, second dy dx of pi, that is equal to negative 4.4. So this is a negative. So since the second derivative is negative, the graph is concave down. So the critical point q equal 90 is the maximum point, or maximum quantity that the quantity that maximize the total profit, since this equation now is belong to the profit function. Okay, so then the next the next question is, let's say, find P, price at maximum profit. So we have Q, the maximum quantity is 90, and then P equal to 400, the demand, P times 2Q. So therefore, the price at the maximum quantity, maximum profit, is 400 minus 2 times 90. So the answer is 220. At the maximum profit, the price is 220. So the last question is asked you about find the maximum profit. So in order to find the maximum profit, the quantity is 90, of course. The pi is equal to 316. The pi is equal to negative 2.2 times 90 squared plus 369 times 90 minus 400. So the total maximum profit is 70,420. That's the application of dy dx that we learn now, how to find the maximum or minimum profit. Okay, then so for your homework, I think for your homework, before I stop our class today, for your homework, let's say from this course, okay, please find the quantity that maximize TR. Okay, based on this equation, based on TR and TC. Okay, the next for your homework, find quantity. Let's say find Q that okay, I would like find Q that it's not Q. Okay, find the homework is okay, again I just write the homework based on this equation is the homework is okay, find the extreme point of TR and TC. Okay, the extreme point is a maximum or minimum. You need to decide what is the extreme point, minimum or a maximum, TR and TC. And then the third one is the third question is sketch the graph. Draw TR, TC, and pi in one graph. That is the homework based on this equation. First, you need to find the extreme point, the maximum or minimum. You need to justify whether the extreme point is maximum or minimum by using the first derivative and second derivative for TR and TC. And then the last one, please draw all the graph, TR, TC, and pi in one graph. From that graph, you will see the extreme point of the TR, TC, and also the pi. Okay, I think that's all for today. Okay, I have just finished the topic 6, the part C of topic C, meaning that I have finished the topic 6. And then for the next lecture next week will be held physically in Pusadikan 9. I will continue on the topic 7. That is the integration. Okay, I think that's all for today. Any question? Any question?
No question, Doctor.
No.
Okay, if you have no question, I think that's all for today. Thank you for your attention. I think I can stop now, and then see you next week at Pusanika 9 and then we will discuss the last topic of our lecture. That is topic 7, the integration. Okay, that's all for today, and see you next week.
See you.